Welcome back to one more presentation on the sensor topologies or the sensor networks that are used in your IoT scenario. So in our previous presentation we have seen about the RFID devices, radio frequency identification devices, how exactly they sense the inputs or the data, and how the sensed input goes to the higher layers, right? What are the different security challenges, what are the different physical challenges, and how would these things be overcome, right? All those things we have seen, and some of the examples also we have taken in the previous presentation as long as the RFID devices are concerned. So today we shall discuss about one more such concept, that is called as the wireless sensor network nodes, or the wireless sensor network, WSN. This is called as WSN, wireless sensor network. So basically this wireless sensor network, it can be defined as a network in which each sensor node connects wirelessly and has the capacity of computation for the data compaction, aggregation and analysis, and each one also has the communication as well as the networking capabilities. And basically a wireless sensor network consists of spatially distributed autonomous devices. So this is a very important point to be noted here. Spatially, that means in space, distribute autonomous devices. So this is a very important point to be noted. So basically a wireless network consists of spatially distributed autonomous devices, and where there are different sensors. We have already spoken about what exactly are the sensors right from the beginning. Now these sensors will have the features of the wireless connectivity, as you can see here, wireless sensor network, right? Each node connects wirelessly, and every node has got the capability of computation, data compaction, aggregation as well as the analysis. Now when we say that we have got the computation, data compaction, aggregation and analysis, so these are all coming under the smart sensors, right, which has got not only the measuring ability but also the communication ability. So now in this particular presentation we need to see what are the different attributes of this wireless sensor networks, right? So how they can be architecturally seen, what are the limitations, right? So how would you see them in a typical IoT application? That's what we are supposed to see here. So basically they cooperatively monitor the physical and environmental conditions. So this is a very important word here, cooperatively monitor. That means when one node is deployed for sensing something, it not only acts alone, right? It will act along with the other nodes in the vicinity or in the jurisdiction of that particular network, so that the collective information is provided to the higher layers for the possible analysis and all, right? How exactly we will be able to get the collective information which is measured by one node and which is being coordinated by the different nodes? That all comes under the architectural point of view of wireless sensors node, right? So the wireless sensor network cooperatively monitor the physical and environmental conditions, maybe the temperature, sound, vibration, pressure, motion, or maybe the leakage of hazardous gases, pollutants, at different locations. So this is very important. So now this is where we come close to the IoT applications, right? So you have you must have heard about the gas leakage sensors, or you must have heard about the pollution monitoring sensors and all, right? So you have the analysis. Maybe you must have seen those things deployed in a particular area or particular locality, but if you are able to get the information from so many different localities, then wireless sensor networks are one such solution, right? And this wireless sensor network acquires the data from multiple and remote locations. So that's what gives this particular wireless sensor network a better scope, so that a particular application can easily be implemented with the help of these kind of sensors, irrespective of their physical locality of the measurement and all, right? So it is a network of devices that can communicate the information gathered from monitored field through the wireless links. The data is forwarded, after having measured the data is forwarded through multiple nodes, and maybe you have a gateway, right? And you may have the data transfer to some other network also, depending upon the requirements. This is what is the general definition of what we have as wireless sensor network. Let us move ahead here. The same thing. Okay, now if you look at this diagram, so probably you should be able to understand how exactly you can have the wireless sensor network, right? So here in this particular case, you have so many things like medical monitoring here, right? Vehicle monitoring, animal monitoring, machine monitoring, right? So then monitoring, so many things, right? And of course you have got base station tower or the base station controller, all these things, and you have got the wireless data collection network, right? So now again from here you can see you a server here, right? So then you have got some other system which is called as the data distribution network. The first one is the data acquisition network. So whenever I speak about a sensor network, I concentrate on only the acquisition network, because the sensors are meant for the data acquisition, right? So now in this particular case, you can see you have got a wireless sensor here, right? You have got a wireless sensor here. This is where we are going to concentrate. So the wireless sensors are the physical entities there, but when you speak about the wireless sensor network, all these parameters will come into picture, right? So you may have a PC, or you may have a cellular phone, or you may have a notebook, right? So many things for your analysis purpose. Of course your internet is a major component here, as long as you want to have the analysis of the data which is done at some different locality, right? So this is how you can see the wireless sensor network, right? So you have a base station and so many nodes. There are so many nodes which are again basically the wireless sensors here, right? And these nodes are basically networks that are used to monitor physical or environmental conditions, like what I have just mentioned, maybe sound, pressure, temperature, and all those things. And very importantly, all these informations are cooperatively passed to a network, right? The data is in a coordination manner passed through a network to the main location, right? So the main location is coming somewhere here, where the data analysis and other things are being taken place, right? And accordingly you have got several examples, right? So internet of waste containers, here the sensors wirelessly communicate the waste containers, right? statuses in a management system in a smart city. These are some of the examples, right? Internet of street lights, right? We have already taken an example earlier. What do we mean by internet of street light, right? So here also you have got the wireless sensor nodes which acquire the data of the ambient light conditions at different locations, right? And maybe the wireless sensor node communicating the nearby traffic densities data for the monitoring of the traffic signals. These things have already come into existence or the real-time applications. So these are some of the applications which you can think of as long as the wireless sensor network is concerned, right? And accordingly you have something called as the wireless sensor node. So what exactly a wireless sensor node consists of? Okay, each node includes a radio frequency transmitter and receiver. So this is what is very essential, because whatever the communication has to take place from the wireless sensors in a cooperative manner, that necessitates the wireless sensor network nodes, wherein in each node you have a radio frequency transmitter and receiver, which of course functions as both transmitter as well as the receiver. Okay, then we have again the same definition is coming again, right? I have already told you about this, the definition: network in which each sensor node connects wirelessly, each having the capability of computation for data compaction, aggregation and analysis. Each one has the communication as well as the networking capabilities, and the wireless sensor network consists of spatially distributed autonomous devices which are nothing but the sensors. So here is one example of wireless sensor network, right? If you look at the wireless sensor network, we have basically four or five types of wireless sensor networks. They may be terrestrial, which are on the earth, or you may have the underground wireless sensor networks, underwater wireless sensor network, multimedia wireless sensor network, and even you can have the mobile wireless sensor network. I am not going into those details. So now this particular example is basically a multimedia this is basically a multimedia WSN, right? Multimedia WSN. You can see here what exactly you find in these things, right? I am not going into the other details because the multimedia wireless sensor network, right? So maybe it is used for tracking and monitoring of the events in the form of multimedia. Could it be imaging, could it be video, or could it be audio, right? And basically these network consists of the sensor nodes equipped with maybe the microphones or cameras, right? And each node is interconnected with the other one in the wireless mode, maybe for the purpose of the data compression, or could it be for the data correlation, right? So to match the data, maybe you can take an example of the police security in the form of the CC cameras in cities and all, right? So you can have that kind of application. Even with the help of the drone, you can have the the monitoring being done here. So this is one such example wherein from different localities, right, or you will be able to have the control or the monitoring of the data which is sensed by the different nodes, right? So in this example you can see the infrared camera, you can have the microphones, you can have the video cameras and all. So basically it is a multimedia because it deals with imagings, or it deals with the videos, audios and all, right? And by making use of the microphones and cameras, right? Like that you have the different other type of wireless sensor network. As I already told you, they are the terrestrial wireless sensor networks, right? Or they could be the underwater sensor network, or they could be as I already told you, the underwater wireless sensor network. They may be required in specific applications as per the requirement. And the one which I have just shown you, which is the multimedia wireless sensor network, and the last one, the mobile wireless sensor network. So these are the different 5 types of the wireless sensor networks. And now let us look into the topology that is used in your wireless sensor network, because the topology plays a very important role as long as the sensing of the data is concerned, and as long as the size of the overall network is concerned, right? So now when you come to the topology, again you need not worry much about these things, because we have somewhere looked into these kind of topologies earlier also. One, what we call it as star topology. You please note here that this is the gateway and these are end nodes. I will come to all these points later. One is called as the gateway. You know what is the meaning of the gateway. And the other nodes, the blue one, dark blue one, indicate the router nodes. And very importantly, in the star topology, you don't have anything called router node. You have only the gateway as well as the end nodes. But whereas when you come to the tree and mesh topology, you will be having both along with gateway, you will be having both router nodes as well as the end nodes, right? So star topology, basically each node connects directly to the gateway. If you look at this diagram, each node connects directly to the gateway. This is one node and which is possible for you to directly connect it to the gateway, right? So a single gateway can send or receive a message to several remote nodes, right? The nodes are not permitted to send the message to each other. So this is one topology. It is not possible for these nodes to communicate with each other, right? So what is the advantage when each node is not capable of connecting to the other node? It allows low latency of communication between the remote node and the gateway, right? So the transmission speed will be always higher here, because it doesn't allow the inter end node communication, right? So this is one type. Basically this is called as the star topology, right? And then you have got the next one as the tree topology, which is also referred to as cascaded star topology. The tree topology is also referred to as the cascaded star topology. You can look at the diagram and you will be able to understand why the tree topology is referred to as the cascaded star topology, because it appears like it is the enhanced version of the star topology, right? And the main advantage of this tree topology is that the expansion of the network is easily possible, right? You can keep on adding the things here, right? So expansion is easily possible and the error detection becomes easy. I will come to this particular point, what exactly is the meaning of the error detection here. But here the problem again, as long as the tree topology is concerned, right, it heavily depends on the bus cable, right? So the network is, if suppose any failure takes place somewhere here, all the remaining parts are not able to be getting connected to the gateway. So this is one drawback of going with the tree topology. And the third one is mesh topology, where it allows the transmission of data from one node to another, right? So you have got this node, you have got this, you have got this, you have got this, and by virtue of the routers or the router nodes, it is possible for you to have the connection or the transmission of data from one node to another node, which is not possible in your star topology, right? If a node wants to send a message to another node, right, which is out of the radio communication range, then immediate node can be used to forward that particular message, right? So now let us say that this node and this node are not able to be communicated by virtue of the radio communication range. Then since is directly connected this node to get the communication through this router and this router and to this particular node. This is what is the advantage of mesh topology, and it is easily possible to have the isolation or detection of the faults, right? So one particular part can be made to come out of the overall network. But the drawback here is the network appears to be physically very large, very big, and it requires a lot of investment, right? So this is one thing which I wanted to tell you as long as the wireless sensor network topologies are concerned. The star network, where you don't have any router, every node has to communicate through its dedicated gateway, right? And it is very fast because you don't have the inter node communication possible here. Whereas in the second case, in the tree, it is the expanded or the cascaded version of the star topology. The third one is the mesh, which is physically appearing to be a very large network, which results or which requires a lot of investment and all. So these are the three topologies. What we have seen so far is we have seen the definition of the wireless sensor network. So why the wireless sensor networks are used in the IoT scenario. Then in the wireless sensor network, we have seen the classification of the wireless sensor networks. So with the help of one example, that is the multimedia wireless sensor network, and we have seen three different types of topologies that are used in the wireless sensor network, right? So this, before I take this reprogramming, let us go into the architecture part of the wireless sensor network, right? So when we have seen the star topology, or when we have seen the mesh topology, or when we have seen the third one, that is the tree topology, right? So individually how these topologies are different with respect to each other. So whenever a node wants to communicate to a base station, this is called as base station, this is node. Like that, you may have different nodes, right? N2, N3, something like this, right? So all these are supposed to operate in a coordinated manner, so that all information is properly read, and it is submitted to the upper layers or the network layer for the proper analysis. One or two examples also we have seen, right? So when this is the requirement, how exactly these things are architecturally designed. So that is called as the wireless sensor network node architecture, right? So in this particular architecture, we have three-layer architecture. So basically we have got I will just show you that diagram. When it comes to the architecture of wireless sensor node, so we start with architecture called three-layer architecture. When I speak about the three-layer architecture, one is the physical data link layer, where you have got media access control and physical layer. Then you have got network layer, wherein in the network layer the serial link with data link as well as the media access control, and the third one is the application layer. So these are the three layers which are used in the architecture. Come to that diagram. So if you look at the diagram, it is clear to you now. So here if you look at this particular diagram, you have the sensor here, then sensor node, CPU plus the programming part of it, right? So then you can see
Now, what exactly your application layer does here? Basically this is for the sensor management, right? It is for the purpose of the sensor query, the data dissemination, right? The data is passed on. It may be with respect to the task assignment, right? Or the application specific protocols, right? So they are called as ASP. So that is being taken care of by your application layer there. Okay, the sensor or CPU and the program sensor node, right? So basically they constitute the application and network layer, as you can see here. Sensors, CPU and the sensor node, they constitute the application and network layer. You can see here how exactly the communication takes place there, right? And the network layer, this network layer serially layer maybe to have the coordination, or it may be to have the proper working of a routing software. I think made a mention about the routing software. Whenever some data comes to a particular node, where exactly it has to go or which path it has to follow before it is going to its destination, that is taken care of by your routing software, right? Maybe in the network layer, right? So you have the coordination or the routing software to be taken care of, right? And a serial link, we have got a serial link here. Serial link interconnects the layer to a wireless radio circuit and the antenna, right? So whenever we have the wireless sensor network, you have the sensors, but no information is being communicated over the physical wires, right? So wireless means you must have an antenna, right? You must have an antenna, and that particular task is taken care of by a serial link. A serial link basically interconnects these layers to a wireless radio circuit and antenna, and the radio circuit is basically at the physical or data link layer, and the communication subsystem uses your media access control and other physical data, physical layers protocols, right? So this is how the total communication takes place, right from your sensor network to the communication subsystem, ultimately to reach it to the application layer. So this is what is called as the architecture of wireless sensor node. Three layer: one is the physical, another is the data link, and the third one is the application. Generally we call it as the physical cum data link, or the network as well as the application layer. Okay, so this is one thing. Then we have the network architecture for the connected nodes. So now what I have initially told you is, here I got a base station, this is the base station, and I have got a wireless sensor node. This is the node. Whenever this node or whenever this wireless sensor senses some data, before it is given to the application layer, what different architectural point of view is seen, that we have seen in the previous slide. Now, when you have got multiple nodes here, this is one, this is one, this is one, there may be hundreds of such nodes in a typical system, right? How different nodes communicate with each other, so that in the coordinated manner, how the overall information is being transformed to the layer where it is to be analyzed. That comes under the network architecture of connected nodes. So you should be able to properly, draw the line between the architecture of WSN node, wireless sensor network node, and the architecture of the wireless sensor connected nodes, or the network architecture of the sensors connected nodes.
Wireless sensor node, coordinators, is gateways, routers. This is one. Please let this word fix. This is very important. As long as the architecture of the connected node is concerned, in the network layer, we have got two things. One is called as the fixed connecting infrastructure of wireless nodes. Fixed connecting infrastructure means they are always permanent there, right? So they may be in the form of coordinators. I will tell you what exactly are the coordinators, right? They may be in the form of relays, gateways, routers and all. The second one is mobile ad hoc network of WSN. Mobile ad hoc network of WSN, including the routers, gateways and multi-point relays, right? I will tell you what exactly these things mean. You can look at this diagram now. If you look at this diagram, both the types, right? One is the fixed connecting For the gateways, you have got multi-point relay, and which is taking to your internet. This is one. And if you look at the second diagram, you got multiple nodes, WSN 1, 2, 3, which communicate with each other, and finally you have the access point, then multi-point relay, router or gateway, which is taking it to the internet. So now the difference between these two examples, probably you should be able to understand by virtue of the localities of the different wireless sensor network. So in the first diagram, WSN 1, 2, 3, 4, right? They are all connected to a coordinated wireless sensor network node, but whereas in the second diagram, all these things are connected to access point by means of one particular node, and then they are connected to the router or the gateway, then to the internet, right? So now here basically an access point is a fixed point. We have already seen earlier also what we mean by access point, right? So it is a fixed point transmitter or receiver
which is meant to provide the accessibility to the nodes nearby or the nodes reaching in the wireless range, right. So this is what we mean by access point. And you have got a multi-point relay. You can see here you have got a multi-point relay here. So what is the purpose of this multi-point relay? Basically this multi-point relay connects to the other network, right. Whatever the information you measure from your either WSN1, WSN2, 3 or something like that, right. So if this information is to be transferred to some other network, right, so then this multi-point relay connects the other networks, maybe internet or the mobile service provider network, right. And you have got a router or gateway here, right. What exactly a router's role we have already seen earlier also. A router's role is to select a path for the packet transmission among the presently available path in the network, right. And finally you have got a coordinator here, or the coordination switch, or the coordinating WSN node. Basically a coordinating WSN node provides the link between the two networks. So this is how you have the first part of the architecture, which is called as the fixed connecting infrastructure. Several examples what we have seen earlier, maybe the example of a smart home. You have spoken about one second, home. Okay, so when I speak smart home, what are the different things I can have in a smart home? You have different surveillance points, right. You may have a refrigerator, or you may have air conditioner, right, a microwave oven, TVs, computers, with all the Wi-Fi access points. That's what we call it as the access point here, right. So now you may have in an industrial scenario, for example, right. So the different machines, different stores, the different offices, the different sale points, right. So different plant locations, these are all coming under the identifications here, WSN1. Now in a smart home, what exactly happens is, this could be referred to a refrigerator point, this could be referred to maybe a TV point, or a microwave oven point, right. So this may be a smart plug or something like that, right. So they are all measuring the information at their locality, because everything is connected to Wi-Fi, right. So then whatever you measure there, right, so those informations are gathered, and by means of the multi-point relay or by means of the router or gateway, they may be made to connect to the internet, and somewhere else these informations could be analyzed, and accordingly you may have the control of the different things, even though you are not present at home, so that the different devices can be monitored. So your microwave oven, right, which is required to be turned on for 15 minutes and turned off without your presence. So that kind of action can be taken from a remote location, from wherever you are, right. Suppose by mistake you must have forgotten to turn off the air condition or something like that. So those informations can be sent there, and on your mobile phone you may have the signals or the indications that you have turned on or you have kept the your AC turned on. You can turn off from a remote location. So in order to sense all these signals, we are making use of the wireless sensor network. And please remember, this wireless sensor network is not the only kind of sensor which you have. This is one of the kinds of sensors and which is very popularly used nowadays, right? So the architecture is something like this. How exactly you measure the information, how exactly you read the data. After having read the data, how it is possible for us to have the coordinated operation, right, from all the sensed data which is further put for the processing through your internet or to your application layer or something like that, right. So now as long as the ad hoc networks are concerned, so you have got the second one, right, the second diagram. So this is slightly different from system. You may be using it for habitat monitoring. Habitat monitoring means you have got animals, right, you have got birds, right. So here basically all these things are tied to these birds or animals or habitat monitoring, so which are at a different location, the location of which may keep changing. That is the reason why it is called as the ad hoc network, right. So accordingly you may have a small changes in this connectivity method also, right. So these are the two types of architecture. One is the fixed connecting infrastructure, which is specific to a particular location or particular area or a particular entity, or where all these things are fixed. Could they be wireless nodes, could they be the coordinators, could they be relays, gateways, routers and all, right. As long as the ad hoc network is concerned, you have got the access points or the gateways, routers, multi-point relays, but the way in which you sense the data, so you will not be able to have the confirmation that you will be sensing the data from a fixed location. It may keep changing, right. So the example of which also I have given you just now. So now this is about the architecture of the wireless sensor network nodes. This is very important, right. Earlier we have taken the architecture of only wireless sensor network or a single node, how exactly a single node measures the information and sends it to the other layers.
Sensor network, and finally the two types of architecture. One is the architecture with respect to a wireless sensor node measuring the information and passing on to the higher layers. Then the wireless sensor nodes which are operated in a coordinated manner in order to read the information and send it to the higher layers or to some other network by means of the internet and all, right. So I will stop here. If you have any doubt on these things, please get back to me. In the next class or the next presentation, we will see some other architectures and some of the limitations and other things as long as the wireless sensor network is concerned. Thank you.